So today we are continuing Chapter 6, Section 1. We're still graphing systems of equations. Today I just want to talk about what happens when we encounter a couple of specific situations. If you are graphing and you happen to run across a graph where both of your lines wind up looking something along the lines of this, then what we have here is, of course, two parallel lines. And parallel lines, by definition, do not intersect. And so, since they don't intersect, they can't have a solution where one ordered pair will make both equations true. And so, if you wind up with parallel lines, then what you have, of course, is no solution. Now, on occasion, you will run across a graph where when you go to graph one line, you graph that, and then when you go to graph the second line, it turns out that you graph the same line again. And so notice, of course, that I've got two lines graphed, one right on top of each other. Well, the solution to a systems of equations, of course, is where the two lines intersect. And since the two lines are intersecting sort of basically on top of each other, my answer here is infinitely many solutions. And I am pretty sure that I just butchered the spelling of infinitely, but infinitely many solutions. Many people will refer to this on quizzes and tests as just IMS. And so one of the things that you'll be graphing today is, of course, problems where there might not be a solution at all, and you might wind up graphing the same line twice, which gives you infinitely many solutions. The other thing that you're going to be facing today as you work on a handful of problems is the fact that on occasion your equation is not going to be ready for you to graph just yet. And so if we give you something like 3x plus y is equal to 4, you're going to have to solve for y first. And so we wind up with things like y equals negative 3x plus 4. You might, on occasion, also have to divide. So make sure that if you have something like negative 3x minus 4y equal to, say, 2. Not 2. Let's not go with 2. That's kind of a silly number to use there. Let's go with 8. Adding the 3x to the other side gives me a positive 3x over here plus the 8 that we have. And we're also left with that negative 4y. A lot of people tend to forget that negative. To get y by itself, of course, we're going to divide by negative 4. And so we wind up with y equal to a negative 3 over 4x and then minus 2. And now that's ready to graph the way that we have been graphing problems all along. So not really a whole lot in the way of things that are new today. Just wanted to give you a little bit more information about no solution, infinitely many solutions, and make sure that you're ready to see those. Be diligent in your work today. You've got 3 different assignments, 2 of which I expect you to get finished. You have graphing systems of equations 2, and that's on Delta Math, and then you have a quick 7-question item on Edulastic. And then when you're finished with those, I have an assignment that you will finish up either today or tomorrow. Well, tomorrow, the next day that we meet, either the Thursday or the Friday. And that's solving systems and catching turkeys. If you don't finish that today or overnight, then you'll want to get that finished before the end of class on the next time that you're in my class, because there will be yet another assignment and another video to watch to get a few directions on a new process. So enjoy and watch again if you need, but get started, get busy. Thanks, guys.